we have done last lesson is apply the combination, permutation, and like factorial into probability questions. Okay, how do we deal with probability questions? So I can determine the total number of ways of rearranging those kind of things without any restrictions, and then I will find the number of ways that I want the particular thing happen. I want to see how many number of ways I can do that. I'll use the number 2's result divide by number 1's result, and I will get the probability. Okay, they are all equal likely events. Okay, they are all equal likely events. So I have shown you how to do with example 1, and let's have a look at example 2. Example 2 is the most important question. So in year 12 you will use the knowledge, okay, like exactly this type, okay, exactly this type. Although it won't ask you that explicit, but it is using the knowledge of this question. Okay, so I'll just get the song. Okay, so number 2 says 2 students are to be chosen to represent the class in a debate. Okay, I want 3 students. Okay, I want 3 students. And as I said, to do a debate, I'll select 3 students. You will think about whether the order is important or not. Well, the order is not important because it doesn't matter who will get selected first. It's like 3 of you go to the debate. Well, it doesn't matter who gets selected first. So this is definitely a combination question because order does not important. If the class consists of 6 boys and 4 girls, okay, 10 in total, what is the probability that the team will contain exactly 1 girl and at least 2 girls? Okay, so what I want is select 3 people from 10, and I want to see the probability that exactly 1 girl or at least 2 girls. So why select 3 students from this class? Well, I can have different combination situations. I can have 3 girls, 3 boys, 1 girl, 2 girl, and no girl at all. Like, that's what I can have. So I will think about the total number of ways without any restriction what we can get. So I'll write total here. I'll write total. Can't draw a straight line. Okay, that's straight. Total. I want to know the total number of ways that like I can select 3 students from 10 students. So this is definitely a 10-3 situation. I will select 3 from 10. So I'll say 10C3 as well, or NCR, like something like that, 10C3. Okay, that's the total. Now let's look at specific case. So what I want exactly 1 girl. So if I have 1 girl, how many boys I need? 2. Okay, I need 2 boys. So what I'll do is, how many girls are there? 4 girls. I want to select 1. Times what? Times 6 boys. Select 2. Okay, this is the specific ways I want. How many ways I can have. So this many ways I can have. And over the total. The total is 10-3. Well, it can be too difficult to evaluate by hand, so we can use the calculator. So what we can do for the calculator is a division. Well, the bottom is a menu. Okay, where is the combination? It's all in probability. And you can see factorial, permutation, combination. That's the factorial, that's the NPR thing, and that's the NCR thing. What I want is combination. So combination of what? 10 select 3, so 10 comma 3. That's how you times that in the calculator. And then I have the top menu 5 3. Oh, sorry, I just to bring it up. And I want 4 girls. I want to select 1. So this is definitely a 4. Remember, n1 is n. So 4 1 is just 4. Okay, 4 1 is just 4. Times menu 5 3. I have 6 boys. I want to select 2 out. Okay, so equal half. Okay, equal half. So that's after I put that into the calculator and I get half. So half of the chance there will be at least one girl, okay, in this team. Okay, now I will write half here. Second one, it says that at least 2 girls. I can have 2 girls, 1 boy, plus the ways that like 3 girls and 0 boys. There's 3 girls and 0 boys. At least 2, so 2 or 3. So if I want 2 girls, 1 boy, 4, 2, 6, 1, plus I want 3 girls and no boy, 4, 3, 6, 0. And that's the total number of ways of what I want. And I will divide this by the total number of ways I have, which is 10, 3. Okay, these are very easy to evaluate. Well, I'll write it here. Well, this box is one number times one number plus another number times another one. So the first one is easy, but I'm not going to calculate first. I'll put 6, 1 down first. 6, 1 is definitely a 6. Okay, 6, 1 is definitely a 6. 4, 3 is a 4. Remember, n minus 1 equals to 4. N minus 1 equals to n, so that's 4. 6, 0 is a 1. Okay, 6, 0 is a 1. I guess actually cover all the cases, okay, all the cases. N1, N0, and N minus 1. So that's 6, 4, and 1. Okay, what's 4, 2? 4, 2 is 4 factorial divided by 2 factorial divided by 2 factorial. So the denominator is just a 4. And here is a 4 times 3 factorial. So 4 and 4 get cancelled. What you have is a 3 factorial. 3 factorial is just a 6. Okay, 3 factorial is just a 6. 3 times 2 times 1, so that's a 6. Okay, if you want to evaluate 10, 3, what I can do to 10, 3? 10, 3 is 10 factorial divided by 3 factorial divided by 7 factorial. Okay, 10 factorial divide by that and divide the factor of their difference. So 10. Okay, 10 is 10 times 9 times 8. And I don't care about the 7. It will get cancelled with the bottom. So it's 7 factorial after that. And I have 3. 3 is 3 times 2. Well, I don't care, times 1. So the 3 and 9 have 3. The 2 and 8 get a 4. So I have a 120 here. 10 times 3 times 4. I have a 120. Yeah, what we have here. 6 times 6 is 36. 36 plus 2, which is 40. 40 on 120, that's a third. Okay, that's a third. So this probability is just a third. Yes, 36 plus 4, 40. 40 over 120, that's 1/3. Okay, that's 1/3. That's a times. That's a times. Let's double check it. I want 2 here. I want 1 here. Control C plus Control V. Okay, I can have 3 here and 0 here. Okay, a third. That's a third. You can do it by hand approach or you can use calculators to do it. So that's a third. Okay, any question about this? Nope. Let's have a look at next one. Next one's interesting. There are 10 horses in a horse racing. There are 3 prizes, first place, second place, and third place. You don't know any information about this 10 horses and are asked to guess which horses can get first, second, and third place. What is the probability that you can give correct results? Okay, Okay, there are 10 horses, and basically you want to grab one, put into number 1, grab one, put into number 2, and grab one, put into number 3. And the order must be correct because first place, second place, third place is different. Okay, you must put it in the correct place. So, how many ways you can guess this? Well, let's say we have horse A, B, C, D, F, G. Like, okay, first, second, and third. If you guess like that, and guess like that, those two are two different ways. Okay, those two are two different ways because the order is important. You guess A is number 1 or C is number 1, that's totally different. So what I want to ask is how many ways you can guess it? How many different selections you can do it? Yeah, Angie? Well, you can win one. Like, the way you can win is, like, is correct is one. Okay, how many ways you can guess it correctly? That's only one way because this must be number 1, this must be number 2, this must be number 3. So there's one way you can guess it correctly. But how many ways I can guess it? This is already 2. That's one way I guess. That's one way I guess. So how many more ways I can guess for it? Who says what? I can't hear. 10p3? Yes, that's 10p3 is the total. Because I want to select, okay, 3 horses first and give them an order. Okay, I will grab 3 horses from the 10 and I'll give them an order. Like the 3 horses can arrange in different orders. So 10p3 is the total possible ways I can guess. Okay, total possible ways I can guess. Well, that's one possible ways I will guess. That's another possible ways I can guess. I want to randomly select one and I want to make it correct. What's the probability? It's 1 over 10p3. Okay, there will be only one correct way. Okay, I will just randomly do one I want to be correct. So that's 1 out of the total, which is 1 on 10p3. Okay, so this question is interesting because it's not explicitly tell you what is your interest. Okay, what is number 2, like what's that result will be. That result will just be 1 because there will be only one possibility you guess it correctly. Okay. That's 3. Let's look at number 4. 20 balls numbered from 1 to 20 are placed near a barrel. What is the probability that if 2 balls are randomly selected and they are numbered 7 and 15? Okay, have a think about this question. This question is very interesting. I just want to randomly select 2 balls and I want those 2 balls I select is numbered 7 and 15. Let's have a think about that. I'll give you another view, not using combination or permutation. Do you think the order is important or not? No. Okay, I just want to have a result that there are 2 balls in my hand that are numbered 7 and 15. Okay, so if you have your hand, go inside, grab 1 ball. Okay, just don't look at it, put in another hand, and then grab another one and put in hand. And open the hand, there's 7 and 15 there. How many ways like we can have a 7 and 15? If you say 2, then you say order is important. The result I want to see is a ball 7 and the ball 15 in my hand. The order is not important. Okay, there's only one situation after you open your hand, there will be ball 7 and 15. That's like 7 and 15 there. Like whether it's on left hand side and right hand side doesn't matter, but there's only one way I can have 7 and 15. So how many ways I can select 2 balls from 20 balls? That's 20C2. And there's only one way I can do that. Okay, there's only one possible way. Well, when you do, if you really think about the order important or not, if you can't make it clear, what you can think about is, okay, is something inside and I'm not going to see it and I want 2. I grab 2 at the same time. Don't think about I grab one first and I grab another one. Because if you do things without replacement, you are not placing things back, it will be the same as you randomly just grab two together. Like you grab one and grab another one, it will be the same as you grab two at the same time. Okay, so just don't think about who get first or second. You just think about you hand go in and grab two outside. So you want the ball 7 and ball 15. How many possible ways you have it? It's just like you have a ball 7 and a 15. That's only one way you can get that. So it's a 1 out of that. Or another way you can do it, which is a really not really good way to do it, because it's a tree diagram. It can take longer. So what you can do is, well, I use O represent others. Okay, I use O to represent others. And you get a 7 for the first selection and get 15 for the second selection. Okay, that's what you have. This probability is 18 out of 20. That's 1 out of 20. That's 1 out of 20. After you grab a 7, what you can keep thinking about is you get others or 15. Okay, so the probability you won't get 15 is 1 on 19. Okay, it's 1 on 19. And then you get a 15, you can get others or 7. So what's the probability you can get a 7 is 1 on 19 as well. So it's 1 on 20 times 1 on 19 plus that 1 on 20 times 1 on 19. Okay, it's 2 lots of that. So let's have a look whether they give you the same answer. I haven't really tried using the tree diagram method, but let's have a look whether it's the same. Menu 5-3, and I want 20 and select 2 balls. Is that 1 on 20 times 1 on 19? And I'll times that by 2, so plus the same thing, and they're the same. Okay, they're the same. If you think about the order, you will use tree diagram. You will think about first you get a 7, second you get 15, first you get a 15, and second you get 7. But you can't use the denominator as NCR anymore. Okay, you either think about the tree diagram with orders, or you think about without order, you just grab something. Okay, so that's totally 2 different ways. Most of the students will mix those 2. They will have a 2 on the numerator, and then denominator keep the same. It's a mixed way of tree diagram and the combination method, which is not correct. Okay, and the next one is you have one numbered under 10 and one above 15. Okay, so under 10 is I have number 1 to 9. Above 15 is 16 to 20. Okay, and something in middle. Okay, 10 to 15 in middle. So how many numbers in group 1 to 9? There are 9 numbers in that group. And the 10 group. Above 15 group, 5. Okay, above 15 group, there are 5. So that's 14. I have a 6 here. Okay, so number 10 to 15. 10, 11, 12, 13, 14, 15. So 6 numbers here. So I want to select 1 under 10. I have 1 here. 1 above 15. 1 here. And 0 in the middle. Okay, that's 3 subgroup. I have cut the things into 3 subgroup. And I want 1 from one subgroup, the other one from the other subgroup, and 0 from the last group. Okay, so what I can write here is 9, 1, 6, 0, and 5, 1 over 20 and 2. So what I can have is a 9 times 1 times 5 over 190. That becomes 1. 38 is 9 on 38. Okay. The last one says, what is the probability that if one ball is randomly selected and replaced? Okay, when you see the word replaced, you cannot use NCR because NCR only deal with without replacement situation. Okay, so you can't repeatedly have something. So when you get replaced, that will be a totally different thing. Okay, that would be a totally different thing. So then another ball is randomly select. So you have one ball select and replace, and have another ball randomly select, and then we have two balls in hand. What's the probability that both balls are numbered under 10? Okay, both balls I want to have number 10. Let's have a think. We have 20 balls. We select one and we replace that back. We still have 20 balls. So how many ways in total? That's 20 times 20. Okay, that's 20 times 20. Why is 20 times 20? F number 1 to 20 first. There's 20 selections in the first box. Okay, what's number 2 I can have? I still have 20 ways I can select it. So it's 20 times 20. So how many ways I can have balls number under 10? I will have 9 times 9 because I can have 9 balls get selected in the first one and 9 balls I can get selected in the second one as well. So it's a 9 times 9. So it's 81 over 400. Okay, any questions? Questions? Nope. Okay, with replacement and without replacement is a big difference. Okay, there are big difference. So one you use NCR and the other one you can just use the random thinking method. Okay, what I can have for the first, what I can have for the second. Alright, so the next thing I'll talk about is the separate page I give you. Where is it? 11, 10, exercise 10E. Okay, it's called the Pascal triangle. Well, we don't really use it a lot, but like in some, maybe in 3 years you can have seen it once, like you use that, and this year's trial exam you can see this Pascal triangle. I think that's why we bring this back and trying to teach it. Okay, last year I don't feel I have to teach it. I think I teach in year 10 but not in year 11, and then this year 11 come to teach it again. So what Pascal triangle used for is for expanding polynomials. Okay, so I'll just let you know what we use that for. What we learn in this exercise is nothing to do with the exercise before. Okay, NCR can be used in many ways. Okay, one way is in the what is called the probability thing. We can use that for selection to represent that. But in another place we can use it is in expanding polynomials. No, that's what I'm explaining. Like we can maybe only see it once in 3 years, or like it's only in trial exam. But sometimes you can avoid this method. You're not necessarily using this method because, for example, you're expanding polynomials. You can just manually expand it. Okay, so well, if it's too large, like power of 10, like you can't do it. But still, if you use Pascal triangle, it's still a lot of work. So if it's power 5, I can still just manually expand it by my hand. So not necessarily using this method, but this can be quicker if you use it. Okay, it can be quicker. So first of all, introduce the Pascal triangle. So what is the Pascal triangle? Okay, we see it here. We call that row 0, row 1, row 2, row 3, row 4, and row 5. And n is the number of terms we have in this row. Okay, number of terms in this row. We have row 0 and have n is the number of rows. So n0 and n1, n2, n3. So okay, this row 0, row 1, row 2, row 3. And let's have a look at the number. It's a triangle shape. And what's the important things about the number? Well, first of all the two side values is 1, 1, 1, 1, 1. And, okay, all the rest place is actually 0. Okay, all the rest place is actually 0. Well, I can't really draw it well. But, like, this one add up together to give you this 2. Okay, 1 and 2 add up to give you 3. 1 and 2 to give you 3. 1 and 3 give you 4. 3 and 3 give you 6. 1 and 3 give you that. Okay, so you just keep adding 2 together and give you the next one. So let's have a write about the last, like after this row 5. Let's write a row 6 by myself. So what's the row 6 will look like? I will have 1. Okay, this side, and 1 plus 5 is a 6. 5 plus 10 is a 15. 10 plus 10 is a 20. 10 plus 5 is a 15. And 6. And the last number must be 1. Okay? So that's what we have. We can keep going forever. Like, you can have infinitely many numbers. But what we use that for? Why this triangle is helpful? This triangle is the same as we write those terms. Okay. First one is n select n. Second row is n select 0, 1 select 0, 1 select 1. 2 select 0, 2 select 1, 2 select 2. So this is row 0. Okay, the top number is 0. There's nothing to select. And this one is row 1. Okay, 1 to select. So top one is 1. I have 1 in total. I can select 0 items and 1 item. And this one is row 2. I have 2 on top. I can select 0, select 1, select 2. Okay, this number, you can map it back to that number because that's 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. And I have 2 here, 3 here, 3 here, 4 here, 6 here, 4 here, 5 here, 10 here, 10 here, and 5 here, and 1 for that. Okay, so they are equivalent. Okay, that's the same image. Okay, they're the same thing. So I can use the Pascal triangle to evaluate any NCR quickly by looking at the triangle. Find out where is it and find out which number, like which row, which column is that, and I can find out the answer. Okay, without evaluating. We just keep adding. Well, even though we have that, if I want 110, think about how many rows you will do. Well, that's too much. Okay, it's still just helpful for number maybe within 10. Okay, maybe within 10, and it's quicker to do by this way. All right. Pascal identities. So what's the identity says? So n select R will be the next row, like one row above, and select one less thing plus that row select the same thing. So basically it's talking about this one equals to those two add together. Okay, do you understand that? It's like NR is that one. The previous row select one less is that one. The previous row select the same number, same amount is that one. So basically what we mean is those two add up to give you the bottom number. Okay, so it's those top one add up to give you the bottom one. That's why we have this Pascal triangle. You don't need to really know that. And well, the proof. Well, I'll show you the proof. It says it is true. Let's say why it is true. So NR is n factorial. R factorial. N minus R factorial. That's my left hand side. Okay, that's my left hand side. So what my right hand side is? N minus 1 R minus 1 plus N minus 1 R. Well, I can't remember if I still can do it, but let's try. Well, it's just a lot of proof and a lot of calculations here. This one will be n minus 1 factorial. Divide by r minus 1 factorial. Divide by what? N minus 1 minus r minus 1. That factorial. That's what we should write here. Let's simplify it. N minus 1 minus r plus 1. So that's just a n minus r factorial. Okay? N minus r factorial. The top minus the bottom, you have n minus r and then factorial. Plus what? N minus 1 factorial over r factorial over n minus r minus 1 factorial. Okay, let's do something to that. N minus 1 factorial. Okay, this one will be, still keep it like that. And be careful what I write here. So that's n minus r times the next number. What's the next? Is n minus r minus 1 factorial. Okay, I have changed this one to that one. Plus n minus 1 factorial over r. Okay, r, I will do r with r times r minus 1 factorial. And then I want to have n minus r minus 1 factorial. Alright. Seriously, I don't know what I'm like really trying to make, but like that's the way I should make it. Well, I know I should expand in that way because those two numbers really just one different. So what I'm trying to do now, maybe well, common factors. Maybe I'll think about the common denominators I can make. So, but I can already see that they are the same. I just want to see what's a better ways to prove on this. Let's time. Yep. Let's time something on this one. I will times the r on this one. Okay, I will use green color. I will times r here, and I will times n minus. Oh, I should use another color. N minus r here. Okay, can you see that now they all look the same? Can you see they look the same now, like the denominator? Can you see it? Everyone got n minus r factorial, got n minus r, n minus r minus 1 factorial, and r. That one got r, n minus r, n minus r minus 1, and n minus r. Okay? Four terms, and they're exactly the same. So it's the same denominator. If it's the same denominator, now I can add the numerator. I can add the numerator. And I will put my denominator together. But when I put my denominator together, okay, this r minus 1 factorial times n minus r times n minus r minus 1 factorial times r. Okay, let's have a look. I will circle this one and this one. Okay, those two numbers becomes r factorial, and those two numbers become n minus r factorial. Okay, I combine two. I group two and group the other two. There is r factorial and n minus r factorial. And the top is interesting as well. I can say that's n minus 1 factorial times bracket r plus n minus r. Okay, find the common factor, which is n minus 1 factorial. And I have n left in this bracket. That's just the n. Overall, that's n. R plus n minus r, that's the n. So the top one becomes n factorial now. And the bottom is r factorial n minus r factorial. And that's left hand side and right hand side, they are equivalent. Okay, left hand side and right hand side, they are equivalent. Questions? Well, I know you have a lot of questions. But you don't really need to know this. They're just like for fun. Let's do something fun. Yeah, that's fun. Okay, we'll do more like that. But it's just like you keep using the formula. You only use one formula. It's like n equals to n times n factorial is equals to n times n minus 1 factorial. Just keep using that formula. But like, just for fun, okay? So, well, it shows you why the top two add up will give you the bottom two, okay? That shows you why the top two add up will give you the bottom two. That's all. That's all I want to show. Okay, let's evaluate 6, 3. Okay, 6, 3 is row 6. Don't forget, you start counting at row 0. Okay, row 0 is your first row. Row 0, row 1, row 2, row 3, row 4. Let's count. I have my row 6 here. Okay, row 6 is here. And number 3 is that one. So it's a 15. Okay, row 6, number 3. Okay, 6, 3 is a 15. So evaluate that. That's just a 15 using the Pascal triangle. Let's test whether it is that. Oh, it's a 20. Wait. Row 6. Which row is that? 0, 1, 2, 3, 4, 5, 6. Let's have a look what's wrong. I will make it looks better. Oh, no. Okay, 3 is actually the false number. Okay, we'll select from 0, 1, 2, 3. Okay, it's actually the false number. You all start counting from 0. So row 6 is start from counting 0, 1, 2, 3, 4, 5, 6. And then select the 3. You count from 0, 1, 2, 3. Okay, so this way start from 0 and this way start from 0 as well. So we have 1, 6, 15, 20, 15, 6, and 0. So you start from row 1, 2, 3, 4, 5, 6. Okay, you end up this row. And then you select 3. So you count from select 0, select 1, select 2, and then select 3. That's the 20. You get counting. See we start from the 0. We start from the 0. So we have 20 here. That's not 15. It's good we check in the calculator. Okay, so that's a 20. Alright, expanding theorem. Okay, that's all what we want to know. I will let you know the formula first. Okay, the formula first. So if it's only work for a plus b to the power of n, okay? So if it's a minus b to the power of n, what you need to do, you make it a plus minus b, and then to the power of n. The b is actually minus, the negative number, okay? The second number is actually plus a minus, plus a negative number. So you can't expanding by minus sign in between, it must be plus sign in between. And you can treat that number as a negative number, that's no problem. So if you have a plus b to the power of n, after expand, there will be n plus 1 terms. Okay, there will be n plus 1 terms. Let's think about the quadratic. Okay, a plus b squared, perfect square, is a squared plus 2ab plus b squared, right? So how many terms? 3 terms. Okay, there are 3 terms. So therefore, it's n plus 1 terms. The power of 2, you have 3 terms. I have to think about the cubic. A plus b cubed. So it's a cubed plus 3ab a squared b plus 3ab squared and plus b cubed. So 4 terms. So to the power of 3, you have 4 terms. So it's always one more. Okay, one more terms after you expand it. Alright. Oh, let's do this. So it's n term, n plus 1 term. So I'm not going to write like a lot, but the pattern is, okay, what I want you to write is sum bracket and A and a B plus a bracket A and a B. I'll give some space, okay? I'll do it at like in one go. Okay, plus dot 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 plus alright. A little bit too small over there, but that's fine. Okay, so why I write this? First of all, what's the bracket? You understand that's NCR, okay? That's the NCR. So the coefficient, that's the coefficient. So what's the coefficient will be? You start from N0, N1, N2. Well, keep going, N3, N4, N5, whatever, until N. So the previous one will be N minus 1. Alright. And then we have the power of n. Okay, a plus b to the power of n. What you will know is like in every single term, the power add up should be the same as n. Okay, the add up should give you n. So I will start from this one. Okay, I will fill the bracket first. That's n0, n1, n2, n3, dot dot dot, n minus 1 and n. So I am going to fill in the power with a now. What the power of a? We start from the highest, so it's n. And n minus 1, n minus 2, dot dot dot, and that's 1, and that's a 0. You reduce it until 0. So then oppositely, what's the b's power will be? You start from 0, because they need to add up, give you 0. You start from 0. 1, 2, 3, 4, 5, 6, 7, n in the end, and that's n minus 1. It's a very easy pattern. Okay, it's a very easy pattern. You just need to fill in the powers. Okay, start from n, n minus 1, n minus 2, n minus 3, and then come back 1, 2, 0, 1, 2, 3. Don't forget 0. Everything start with 0 and finish with 0. Okay, like the NCR thing, you select from 0. You count the rows start from 0. So everything start from 0 in polynomial expansion. Okay, so example 2, ask you to extend the following. Okay, expand the following. That's to the power 4. I want 5 terms. Okay, there will be 5 terms, and the a is 1, b is 2x. I'll write it on top. Maybe there's more space here. So I will write first. I will write bracket. Okay, 1 to the power of something, and then 2x to the power of something, plus the bracket 1 to the power of something, 2x, plus not enough, but well, that's fine. 1, 2, 3, 4. I should have one more. So that. Okay, 5 terms. So what I'll fill in with is start from 4. So that's a 4 on top. 4, 0, 4, 1, 4, 2, 4, 3, and 4, 4. For the A, I will start from 4, 3, 2, 1, 0. 0, 1, 2, 3, 4. Okay, and then we evaluate that. So what's the 4, 0, 4, 1, 4, 2, 4, 3, and 4, 4 will be? You just look at the Pascal triangle, okay? Row 4, okay? Row 0, row 1, row 2, row 3, and row 4. The coefficient will be 1, 4, 6, 4, 1. Okay, 1, 4, 6, 4, 1. Okay, just this row. So I don't need to evaluate, just go back to the table. 1, 4, 6, 4, 1. That's the value of this. So what that equals to? That's 1 times 1 times 1 for the first term. For the second term is 4 times 1 times 2x. For the third term, what you have is 6 times 1 times 4x squared. For the next one, what you have is 4 times 1 times 8x cubed plus 1 times 1 times 16x to the power 4. Okay, so what do you have? I'll write from the highest power 1, 16x to the power 4 plus 4 times 8, so 32 x to the power 3 plus 24x to the power 2 plus 8x and plus 1. Okay, that's the expanding form. That's the expanding form. Well, I'll start to write the next. Yes? Yep. I'll write this one. Well, there will be 6 terms for the next one, and the minus I must write as 3 plus minus 2x and then to the power 5. One, two, three, 4. I should have 5 and 6. Okay, 6 terms here. I will have 5. So 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, and 5, 5. Okay, so 0, 1, 2, 3, 4, 5, 0, 1, 2. Wait, I write 0, 1. Where's my 1? 1 is here. 2 is here. 3 is here, 4 is here, 5 is here. You need to check the add up should give you 5. Okay, that's the expansion form. And I go to row 5. Before it's row 4, so row 5 is here. So row 5, what we have is 1, 5, 10, 10, 5, 1. Okay, 1, 5, 10, 10, 5, 1. So 1, 5, 10, 10, 5, 1. So what I have is, this is 1 times 3 to the power 5, and then to the power of 0, that's 1, plus 5 times 3 to the power 4 times negative 2x. Okay, so that sign become a minus sign. The next one is plus 10 times 3 to the power of 3 times 4x squared. That's still a plus sign. Plus 10 times, well, 3 to the power of 2 is 9 times minus 8x cubed. And keep going, plus 5 times 3 times 16x to the power of 4. Plus, well, that's 1 times 1 to the power of negative 32x to the power of 5. Okay, so 2 over 5 is still minus. So 2 times 2 times 2 times 2 times 2 is 32, but it's a minus 32. And you can calculate whether plus, minus, what are they, like, what is it, you can evaluate from that. So I'm not going to keep doing with that question. So I have expanded to the simplest form already, and you just need to calculate what is it. Okay, you won't get asked like to expand these complex questions. you just use it in some case. Like this year, there's a trial exam. It's a really good example to use Pascal triangles in that question. So better to know it and understand it, and it's a really good way to expand things if it's quite large on the power. Okay, that's the end of chapter 10, and next week we're going to learn chapter 11, which is a really important chapter. Here is 12, chapter 15, oh no, chapter 13 is just that. You will learn that again in chapter 13 next year, but like it's a very important content. So, okay, we'll talk about that next lesson. So you will do more questions in this chapter first, especially the probability part, the probability application of probability. So that exercise, you need to try more questions in that exercise. A to C is alright, you can try some, but don't really need to focus on that. But exercise D, you must understand that. Okay, you must understand that.